I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss examination practice questions for IBSL Math 11. All the questions are selected by my student, Aaria. Let us now recall concepts, apply them in solving questions, discover new strategies, and build on learning. Extended knowledge is important. Let us analyze and record this extended knowledge as tips. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Let us now enjoy the journey of solving questions selected by the student. Hi Arya, how are you doing?
I'm good, Anil sir. How are you?
Very good, very good. Today, what do you want to learn?
So I have a test next week, so I guess we're gonna do a mix of things. There's a little bit of like composite and inverse functions, and there's a little bit of rational functions too, and a little bit of quadratic. So it's very much a combination of like a lot of things.
Great. So please introduce yourself to our audience so that they exactly know who you are, and then we'll begin our class. Yes.
Well, my name is Aaria. I'm a grade 11 IB student. I'm doing SL, like SL meaning standard level, AA, and I'm one of Anil's students. So
Great. So you can share whatever questions you have. We'll begin from there and let's see how it goes.
sure. I just need to pull the file
Sure.
that I have. Just give me 1 second. Can you see
Yes,
this?
I can. Yes, yes.
Okay. Just going to go into my shared files. And so these are the questions, but I think we're gonna start from the bottom and
Okay.
try as many as we can.
Sure.
Just so that, because all the questions are good, but there's some that I just want to work on the
Sure.
most. Okay. So this is the first one, but actually I think I solved this one. So let me just give me 1 second.
No problem.
Oh, it was this one.
Great.
Yes.
So can you please read the question?
So the question is, find the solution of ln 2 plus e to the power of negative x to equals 2, correct to 3 significant figures.
Right. So let's begin by writing the equation. We have ln 2 plus e to the power of negative x equals to 2. So, Arya, what do you think should be the first step?
So if we're finding the solution, I would say that I would take e to the power on both sides,
Correct.
just so that we can remove the ln.
Yes. So writing it in exponential form. So we get 2 plus e to the power of minus x equals to e squared. Is that clear to you?
Yes, because of the rule where if anything to the power of e,
So
ln.
e to the power of ln, let us say a, will be equals to e, correct?
A. Yeah.
They are reciprocal functions. And now you can isolate e, right?
Yeah, so I'll bring
E
the
squared is a constant. Remember that. Yeah, next step.
So would I bring the 2 to the other side first?
Yes, yes.
So e to the power of negative x equals e squared minus 2.
Correct.
And then Now would I take ln of both sides because I have e and e?
No. That e is a constant. So e to the power of minus x. Okay, you can take long. You can take ln and you can do it
If I
for
take
sure.
ln, wouldn't that just bring me back to the first original question? So that's not
No,
solving
no,
it.
no. The right hand side is a constant. Note,
Okay.
right hand side is a constant. So
Okay.
if you take ln, I prefer to say ln. In that case, you will get a constant on the right hand side and you'll get the value of minus x. You get the idea.
Yeah.
So
So
if I
what
take ln e to the power of minus x equals to ln e square minus 2, that will give me the value
it
of
would be the same thing, right?
minus x
Yeah. Minus
equals
x
to
equals e squared
ln
minus 2.
e square minus 2, right? So what is x equals to? Minus of ln e square minus 2. So you got a value of x. You get the idea.
Yes.
That's a solution. You can use calculator, find this value.
Oh.
Yeah,
Okay, that's
e
it.
square is a constant. So remember that part, okay? So I think that confused you, right?
Yeah.
It is a
I was
constant.
just I was just wondering like, oh wait, don't I have to remove it? But no, it's just a constant.
Perfect.
Okay. So now
Definitely irrational number, but a constant. You have your answer right there.
ln of e squared minus 2.
Yes.
It's negative 1.68.
Three significant figures. Negative
Yes.
1.68.
68.
That's how you're going to do it. Is
Yeah,
it clear?
that's clear. I just forgot that the e squared was a constant, so that's why I was like, huh, wait a minute, don't I have to take ln of both to like get the actual value? But I was wondering, so here,
Yes.
if supposedly I was to decide that if supposedly I was going to take e squared minus 2, could I actually use my calculator and find the actual value of e squared and then subtract that by 2 and then take the ln of that to find this value? Would it be the same thing?
You have to use the calculator anyway. So at earlier you use it, at this stage it is better for
Okay.
you. Yes.
So, like, I can just go, for example, e to the power of 2 and then subtract that by negative 2 and take the
Correct.
ln of this value that I
Correct.
get, and then
And
I'll get
then
the same
negative of
value.
that is yours.
Okay.
Perfect. So if that
Uh,
is clear, we can move on to the next question.
yes, that is clear.
Very.
Okay. This one kind of confused me. So I got up to here where I was able to get the value with like showing that f of g of x
Yep.
equals 1/4 x to the power of 4 minus 2x squared plus 2 because you were just using a composite function here to just show that LHS equals RHS. And
Correct.
then I even graphed it, which was totally fine. Sorry, it just zoomed in. But here my issue is that the equation of f of g of x equals k has exactly two solutions for this limit. Find the possible values of k. I didn't know how to proceed from.
Okay. So let us say this is given to you. F of x equals to 1 over 4 x square minus 2.
Okay.
G of x is also a quadratic function, x square minus 2, both belongs to real numbers. Now you found function of function, and which is 1/4 x to the power of 4 minus 2x squared plus 2. Let's say you come to this stage. On the following grid, sketch the graph of this quadratic function, right? So
Yes.
this quadratic function is x to the power of 4 minus 2x squared plus 2, and you have the value from 0 to 3, both included. How did you sketch this graph, and how did your graph look like? Can you tell me, please?
So when I sketched this graph, the first thing I did, would it just be easier if we just start the question from again?
Sure. Yeah,
Just
I don't
to
mind.
just
Yes.
to make sure like I did the steps right?
Yes. So
Okay.
when we say f of g, so we'll write f of, I can write like this also, which is same as f of the function g is given to us as x squared minus 4. And since the function is 1/4, x squared minus 2. I will write this as 1/4. And instead of x, I will write x squared minus 4 and whole square minus 2. Is this step clear to you?
Minus 2, but for the oh yes, that is
Because,
clear.
yeah,
Sorry,
the argument is
looking at
x.
I was looking at the answer for a minute. I was like, wait a minute, don't you have to do the minus 2x squared as well? But no, the actual
We'll
question.
expand this and simplify, right? So a
Yeah.
squared, which is x to the power 4,
So
minus 2 will be 8x, right? And
yes,
plus 16 minus 2, right?
yes,
And
it's clear.
open the bracket, 1/4 of x to the power of 4, and half of that is 2 times x, and this is plus 4 minus 2, which is 1/4 x to the power of 4 minus 2x, and that gives you plus 2, right? We get the same thing, right?
Yes.
So we have done the first part. Let me erase this. I need the screen really. And then work it out, correct? So we
Yes.
have this particular function. Now
So
you have to sketch this function.
on
How
an
will you sketch
exam,
this function?
sorry,
Can
on a
you
second.
factor?
On an exam, to prove that f of if they give a question like this right here, f of g of x, would I just say LHS equals RHS, therefore it's proven correct?
You can
That
say that. You can say
argument
that. When you
was
come to
equivalent?
that result, you can say hence it is, yeah. You
Okay.
could say that. Yeah, no problems. Now you could factor this, correct?
Yes.
So you can see 1/4 common. So let's call this function as h of x, or y you can say, right?
Yeah.
And so we could take 1/4 common. So we get x to the power of 4. And here we have minus 8x squared. And then we have plus 4 times 2, 8. Is it okay?
I don't quite understand how you got to this point here.
I took 1/4 common. I want to factor this.
Okay. Oh, so
It
to
cannot be
take
factored, right?
oh, I understand. So to take 1/4, you multiply by 4. Got it.
Yeah, so it cannot be factored, right?
Yes.
So let me clear this. So basically, you have a domain from 0 to 3. So why not plug in values and make a table, correct?
Okay.
So that is better for you. So at this moment, let's make a table here so that we get some points and we have the function. Let's take some values over x and we'll put f of g. So when you plug in 0, let's take points 0, 1, 2, and 3 for now. Calculate
Okay.
the values. What do you get?
0, 1, 2, and 3.
Use
Okay.
calculator.
Yes. I have to do that. So, for the first value, the answer will just be 2 because
Yes.
if you multiply anything by 0, it's 0, and then just plus 2, so it'll just be 2. And then for the second one, I just have to calculate that.
Yes.
So the second value is 1/4.
Correct.
2 to the power 4 is 16. So 16 over 4, so that's 4 minus 4 plus 2. The second value is the third value, sorry, is also 2.
Add 2, it is 2. Okay.
And the third value would be 9 times 9, which is 81 over 4 minus 6 plus 2, which gives us 65 over 4, which is not the best value. So I'd say we continue with the 3 values that are given.
No problems. So you have this value, you have this, sorry. You have second value at 2, and then a very large value at 3. So it's
Yes.
kind of like we can just say somewhere else.
And we could also take a negative value as well because these are even powers. So
Correct.
if you were to say take -1 and do that to the power 4, it just give you 1/4, and then the same over here, except it would just be 1 over 4 plus 2 plus 2, which would give us 17 over 4. But again, it's a fraction, so it's not the best like useful value.
Right. So let's try to understand. We are given a domain which is from 0 to 3, and both are included, right?
Yes.
So we have to take only these values, and the graph which we get is kind of like this. Is it okay?
Yes.
And let us see, this is the final value. 65/4, whatever it is, at 3, right? Let's say somewhere here. Is it okay? So we have our graph where let me just redo it more accurately. So 1/4 is, this is half. I mean, and then half of half is 1/4. So we have this part.
Is it a parabola that we've
No,
got?
no, it's not a parabola. It's a
Oh, it's a
quadratic function,
quadratic.
but we are looking into a smaller section, right?
Yes,
So it's a quadratic function.
because it's x to the power of 4.
Yes. But we are looking into one part which is kind of like this. Is it okay? And
Yes.
behavior, we know we could actually sketch this function, but this is how it is going to look in the given domain, where
What
the
would the
lowest
end
value is
be
1
for this?
over 4 at 1. Correct?
The lowest value is 1/4, 1, because that's where the vertex is right here
Yes.
for the y value. Okay.
Yes. Now the question is, if you carefully look at the equation has exactly two solutions for this. So two solutions mean for what value of y do we have two solutions? So y value could be either 2 or more than 1/4. Do you see that? Then you have two solutions. Any line will cut the graph at 2 points in this domain.
Okay.
So you will say that the k value could be greater than or equal to 0, right?
Okay.
Sorry, k, that is the end product, right? Greater,
It
let
can be
me just,
greater than or equal to 1/4.
yeah, greater than 1/4, because at 1/4 you have only one solution. So
Okay.
greater than 1/4 and less than equal to 2.
2.
So
But
that
why
becomes
is
the
it
value of k and the answer for the question.
but, how is it always just the y values that we're looking at when we're
Yes.
looking at
So
the
because they wrote f of x, where they're writing f of g of x is basically equal to k. So k is the output, the y value, correct?
Oh, okay. So when they ask for a question like this, you're trying to find like a range, basically?
Yes. Yes.
Okay. So the range for this would be our minimum value and basically our y-intercept, or our maximum value that is provided, because
Yeah. In this case,
in
if
this
you do
case,
a
because
horizontal line, the horizontal line should cut the graph at 2 points.
okay.
So more than y value of greater than 1/4, it will cut at 2 points. At 1/4, it will cut only at 1 point. So that is not a part of solution. Perfect.
Okay.
So
Okay,
that becomes the k value. Good question. Yes. So did you understand the concept?
Yes, so whenever they ask for two solutions, in this case, and because sometimes they don't write like f of x equals to, they'll put like an output of k
Yeah.
because it's equal to, because obviously it should have been a telltale that there's an x here, so they're obviously looking for your y value. So you want to basically graph it first and then see your minimum and also your maximum, and those will be your I guess cycle values. My only question is, why is this greater than and equal to 2, and why is this just greater than 1/4?
Okay. At 2, we still have two solutions. Do you see that? One solution is 0, the other one is 2.
Okay,
Therefore, you can include 2.
but
But at
one
1/4, we have only one solution. We are looking for exactly two solutions.
okay,
That is why.
I understand. So for 1/4 over here, we only have 1 here, but for 2,
Yeah.
we have 1 and 2.
Yeah. Anywhere in between, we have two solutions. Up to x equals to 2.
Okay. I also thought it was because it was the y-intercept, that's why it's included, but
No,
maybe
no,
I'm
no.
okay. I'll move on to the next question.
Sure. Let me clear this. Yes.
Is it not moving?
Yeah,
Oops.
now it is. Yeah.
Okay,
So you have worked on a lot of questions.
yeah,
Hard work. Good job.
a lot of questions because I just wanted to make sure that I get it. This was the one that was like most difficult for me because I didn't really understand what they're trying to like ask me.
Okay.
Um,
Read
it
the
was
question.
so the first part of it is that let f of x equal x to the power of 4, minus x to the power of 3 minus 5x squared plus 3x plus 2. For x is an element of the real numbers. They want us to solve the inequality so that f of x has to be less than 0.
Okay. Next part.
So
Read B also.
B, for the graph of y equals f of x, find the coordinates of the local maximum point. Round your answers to 3 significant figures.
Okay. Then next part also.
The domain of f is now restricted to AB, where A and B are an element of the real numbers. Write down the smallest value of A has to be less than 0, and largest value of B has to be greater than 0, for which f has an inverse. Give your answers to corrected 3 significant figures. And for these values A and B, sketch the graphs of y equals f of x and y equals f inverse of f of x on the same set of axes, showing clearly the coordinates of the endpoints of each curve. Solve the equation of f of x inverse equals -1.
Correct. So basically, you have to solve the inequality. You have to sketch the graphs. There are a couple of things that you have to do here. Solve the inequality.
Okay.
Also sketch the graph. And based on these two things, you can actually answer all other questions. When they are saying to find the inverse of the function, as you know, as you do in for quadratic functions also, you might have to restrict the domain and range to ensure that it passes the horizontal line test, correct?
Yes.
So the later half is based on horizontal line test. That will give you the value of A and B for this particular condition. So let's begin by answering the first part of it. How do you factor? Do you remember the remainder theorem?
I don't think I've learned a remainder theorem.
Oh,
Or is it just factoring in general?
okay. Remainder theorem we could have used to factor this. So if you are given to factor this, how will you factor?
I would start with the x values.
Like put one by one, right?
Yeah, I would take them one by
Yes,
one.
yes. That is really remainder theorem. So the values to try are actually factors of 2. So you have to only try the value plus minus 1 and plus minus 2. So if I find what is f of minus 1, can you calculate please?
Oh, so f of -1 would be 1 plus 1 minus 5 minus 3 plus 2. So that would be 1 minus 5 minus 3 plus 2, which is -4, -3 plus 2, which is -5.
Not 0, you see.
No.
So it is not 0, you get -5. Is it okay? So that's not the root. Now plug in 1 in it. So what do you get? 1.
Okay.
1
1 minus 1 minus 5 plus 3 plus 2 is 0.
So it is a factor. So when you get a 0, that means it is a factor, right? So putting x equals to 1 is a factor. That means x minus 1 is a factor. Is that clear to you?
I'm not sure what's quite going on with this.
No, because unfortunately, you have not learned this technique, but I'll teach you today. Don't worry.
Okay.
So can you reduce the screen so that I get more space to work? Or
sure.
Yeah, just reduce the screen. Just tell me the equation once after you reduce it.
Okay.
More.
More?
Yeah, more, because I need some. Oh, let me reduce it to minimum.
Okay. Is this good?
No, I need a lot of space.
Okay.
Okay, no problem. What I will do, I'll go to a whiteboard. Is it okay?
Yes, that's
You can stop sharing and then I'll go to the whiteboard.
I don't think we've only learned how to factor to the like anything to the power of 2.
Correct.
So
that is why you're having difficulty in this.
Yeah, so we haven't done
Let
this.
me teach you that.
Okay.
So can you please tell me the equation once again?
Okay,
Y equals to x to the power of 4. Yeah.
4 minus x to the power of 3 minus 5x squared plus 3x plus 2.
So what we realize that if x is equals to 1, in that case, y is equals to 1 minus 1 minus 5 plus 3 plus
Plus
2, which
2.
is 0, right? So that
Yes.
really means that x minus 1 is a factor.
Okay.
Why? Let us say x minus 1 is a factor, then some cubic function will be the other factor, correct? Because it is to the power of 4, correct? So you could write this y as equals to x minus 1 times some other function, let's say g of x. Is that okay?
Okay.
Since for 1 it is 0, 0 times anything is 0, right? You understand factor.
Yeah. Yes, I understand.
Now, what we are going to do is because we'll do long division. I'll teach you long division, and so that we can factor and easily get our answer. X to the power of 4 minus x cubed minus 5x squared plus 3x plus 2. And we are dividing by x minus 1 since we know x minus 1 is a factor. So the quotient will be the other factor, which will be cubic in nature. Get the idea?
Kind of. I'm really
Okay, let's go
confused.
through it. Let's go through it. So we
Okay.
can multiply this by x cubed. And when you do that, you get x to the power of 4 minus x cubed, right?
Okay.
And when you subtract it, like you do in long division, this will be 0. You bring
0
down the next term,
minus
which is
5x squared.
minus 5x squared. You can also bring down plus 3x. Is that okay?
Yes, that's okay.
Now, you have to multiply by minus 5x so that minus 5x squared cancels. So minus 5x squared when you multiply, and this becomes plus 5x.
5x, yes.
And when you subtract, you get minus 2x plus 2. And that goes minus 2 times. Is that clear to you?
Okay.
You see the remainder is 0. So that really means that I could write this y as x minus 1 times the quotient, which is x cubed minus 5x minus 2. Is that clear to you?
So how did you get the x minus 1? Is that just because this...
At this stage, we found that substituting 1 in the equation gives me a 0. So
Okay.
that means at 1, the value will be 0. In the graph will cross, it is
Yeah.
an x-intercept. You get the idea?
But why minus 1? Because we chose 1 as our value.
Because if I say x minus 1, when will x minus 1 be 0? When x is 1?
When x is 1. Oh, okay.
That is the idea.
Okay, I understand. Okay, so from here, once we get this factor, you want to do this long division with the...
Correct. Because the factor will be 0, then the whole thing will be 0, right? You get an x-intercept.
Oh, so this is basically how you factor this whole thing,
Yes,
right?
polynomials of higher degree.
Oh, wow. Okay,
Yes.
I've never learned this. This is very cool.
Yeah, good. So
Okay.
now we got a cubic equation. You have to again try with 2. So now substitute x equals to 2. What do you get in this equation?
In this
Because now
equation...
we have to factor this cubic equation, right?
Oh, okay.
So 2 cubed 8, 8 minus 10, and minus
Minus
2 doesn't work, right? However, if I do minus 2, it might work. Do you see that?
Okay. But
If I
okay,
do,
so for the first equation, we start off with 1,
yeah,
and
plus and
then we
minus 1.
start plus and minus 1, and then we start with 2, and then do we just keep increasing in value by 1 each time we do it?
You will soon learn that it has to be factor of 2. So 2 has only 2
Oh,
factors, right? So 2 factors are plus and minus 1 or
1
plus and minus 2.
minus 2.
So whatever number you choose, ultimately that number should divide 2 evenly, right?
So if we were to do, for example, if this was plus 4 right here, right? So then would my factors that I'd have to try out is plus and minus 1, plus and minus 2, plus and minus 4.
Correct.
Oh, okay. I actually like this. Okay.
So use your calculator, it'll be easy.
Okay.
Substitute 2 in x cubed minus 5x minus 2.
We
Check
we
it
did
out.
did we do -2 first already?
No, try negative 2 also.
Okay.
Because
2 to the power of 3 minus 10 minus 2. Okay, that's -4, so that doesn't work. And then -2 to the power of 3 minus 5 times negative 2. Minus 2. That's
Yes,
0.
that is a 0. So we have
Oh,
another factor which is x plus 1. Do you get the idea? X plus 2, sorry. X
x
plus
plus
2 is
2
also a
because
factor.
x minus 2 is 0. So that's why we have to do x plus 2.
Correct. If you substitute minus 2, it will be 0.
Yes. Okay.
So now
Oh,
let's
so now we
divide
do division again.
of x cubed minus 5x minus 2 by x
And
plus 2. So
so I do x squared first.
here is one more thing. Since one term is missing in between, I'll write a placeholder, right? So
Okay.
let me just show you because we'll have a misalignment here. So let me just show you. So it is
Okay.
x cubed. We do not have any x squared terms, right? So I'll write 0x squared. Is that okay?
Yes.
And now it'll be divided by x plus 2. This is called a placeholder. So we have a placeholder only for aligning, because you are dividing, you want things to be aligned. So
Okay.
now you can divide the thing by, let me change the x
Should we
squared.
start with x squared? Yes.
You are right. So x cubed plus 2x squared. And when you subtract, you get minus 2x squared
Minus
minus
5x.
5x.
And
So it's
then
minus 2 times
plus, would we do oh yeah, we do minus because we want the minus to go
minus
away.
2x squared. And then
Plus
minus 4.
minus 4x.
And when you subtract, you get what?
It's minus x minus 2. And so then can we just do minus 1? Minus x minus 2, and then that's 0.
Perfect. Now we have a quadratic equation, right?
Yeah.
You can factor this one.
Oh, okay.
So can you?
So I don't have to utilize this, right?
Yeah. So now, but this
Yeah.
cannot be factored. We got minus here, right? And
No.
minus 1. So plus and minus 1 will give us 0, not 2. And therefore, this quadratic equation cannot be factored, correct?
Correct.
So we could now write a parabola as what? So that parabola y could be written as first factor, which is x minus 1, right?
Yes.
Second factor, x plus 2. And the third factor is x squared minus 2x minus 1.
I thought our second factor was, oh no, wait. Oh, our second factor is x plus 2 because we found that minus 2. Okay, so we have to use our factors that we find and then our remainder that's here. That's why it's called remainder theorem, because you're using
Yes, the remainder should be 0, then it becomes a factor.
Okay, and we do it until the remainder that's there is not factorable.
Yes. Quotient. This is quotient. Till the quotient is not factorable.
So
right?
the quotient is not factorable.
So this x squared minus 2x, if we try product and sum, we are looking for a product of minus 1, correct?
Correct.
However, minus 1 you get only by multiplying plus and minus 1. When you add them, you get 0, not minus 2. And so you cannot factor them, correct?
Correct.
So now you can write down this equation. With this equation, we'll first graph and then find solution of all other parts. Is that okay?
So how do you know when you need to use remainder theorem? Is it usually when you have like a quartic, cubic, and quadratic all together, and they're asking you to factor it so that you can graph it?
So whenever you cannot factor a polynomial of higher degree, use remainder theorem.
Okay.
That's the key, right? Otherwise, it's
That's
very difficult.
because I was trying to factor this and I had no clue because I was taking out the x's, but the x's wouldn't be like
Correct.
factored out. They wouldn't work.
So in grade 11, they do not teach you this. They
They
teach you this in
don't.
grade 12.
Yeah.
So
Even in IB too. They don't teach
even
it.
in IB, yes. Even in IB, they normally skip this part.
Yes.
Normally, they don't even ask this question, but I don't know. Since it is asked in your case, you are
It's
expected
better to know how to do it than sit in an exam and not know. So
correct. So can you please copy this equation and we'll continue from here. I'll
yes.
clear the board.
I already copied it and
Good.
I'll go back to Safari and
So let me write down this function as f of x as equal to what?
f of x is equal to, sorry, my computer is glitching for some
Okay,
reason.
okay. I think it
Uh,
was minus 2x minus 1, right?
sorry. Here we go. Yes, x
Is that
squared
correct?
minus, yes, that's correct. X squared minus 2x minus 1.
Correct.
Correct.
Now we can graph this particular function, right?
Right.
So the last function, we can find the quadratic solution, right? So we can factor this using formula. So x is equal to minus b, which is 2, plus minus b square minus 4ac, which is 4, minus 4 times 1 times minus 1, correct?
Correct.
Over 2a, which is 2 times 1.
Why are we trying to factor this further?
Because you have to graph it, right? We could
Yeah.
not factor using the remainder theorem because we did not have any integer factors.
Oh, so if we find using the quadratic formula what the x values are, then we can also find the x
The
values
other two factors,
that are
yes,
already
yes.
factored. So then we
Yeah,
can
yeah,
just graph it because it has multiple zeros.
yeah, there are 4 zeros, right?
Yes. Okay.
So this gives you 4 plus 4.
Plus
We
4,
could have
yeah.
factored that.
Oh,
B
yeah.
square minus 4ac, we could have factored.
It's x minus 1.
But yeah, 2.
Oh,
I mean, 2 plus minus 2 square root 2, right?
yes.
Over 2. So we get x value as dividing by 2, 1 plus minus square root 2. Is that okay?
Yes.
So we have the other factor also, correct? Is that clear to you?
That's clear.
So finally, I could write my function f of x as equal to x minus 1 times x plus
X
2
plus 2
times x minus
minus
1 plus square root 2. And you can calculate this value approximately. Is that okay? It'll be easy
yes.
for us. Time x minus 1 minus square root 2. Is it okay? Can
Let me
you
just-
calculate approximate value?
Yes, I was just about to do that. 2. So the first value is approximately x minus 2.41. One minus root 2. Sorry. 1 minus root 2. It's giving me, oh, there.
It will be
The
negative.
second value is negative 0.414.
0.414?
Yes,
Is that correct?
that's correct.
Correct. So we have factored form of our equation, correct? Can you
Correct.
copy this and then I'll use a fresh page and we'll graph.
Sure. Equals to x minus x plus 2, x minus 2.4, and x plus 0.414. I also, during this week, I learned the logarithms using your exam papers.
Yeah.
And I figured out, like, that's how I knew how to, like, find the inverse today because it was, like, very simple.
Good job. Good
taking
job.
it.
Yeah, I see many students come to my YouTube channel learning exponential and logarithmic functions. There's collection of some very good videos there.
Yes.
Yeah.
I was
And the contribution, I should say, comes from England. One of my students in England, Amy, she sends me many questions and we discuss them over in similar lessons as we are doing with you.
Okay.
Yeah.
I was just wondering, is there like any other like test papers similar to that?
Yeah, sure, I'll share with you.
Okay, thank you.
Great. So can I erase? You have copied the equation?
Would you like me to share my screen now just to go into the next part of the question?
No, we have to graph this. Next part is to graph and the inequality.
Is it?
Yeah.
So the graph of y equals f of x, find the coordinates of the local maximum point, round your answers to 3 significant figures.
Correct.
Okay.
So
Did we solve the inequality by doing the remainder theorem, we solved the inequality?
Yes.
Okay.
We factored. So we used remainder theorem. To factor. It is also called factor theorem because if the remainder is 0, then it is a factor. So it is given the name factor theorem also, right? Is it okay?
Yes.
Correct. So let me erase this and write down the function now. So y equals to what?
Y equals to x minus 1, x plus 2, x minus 2.41, x plus 0.414.
So we have 4 zeros. So let's write down the zeros which we have.
So x equals 1, minus 2, 2.41, and negative 0.414.
Perfect. So we have these 4 zeros. So these 4 zeros divide our plane into 5 regions, right?
Yes.
So first we'll sketch the graph. Actually, I like to do both the things together just to show you, because the second part is inequality, just to save time.
Okay.
So let's mark the zeros. All are linear, right? All are linear zeros.
Yes.
So the graph will cross like a line. So we have 1 at 1 and maximum is at 2.4. So let me take to the scale. This is 1 for me, right?
Okay.
And then minus 2. So minus 2.
I also have that value.
And 2.54, let's say 2, 3,
2.
and so
Would be like approximately near 2.5. So I'll just go here.
so minus point, let's say this, right? Minus. So we have these values here. And we know this function, end behavior is known to us. The graph basically will be kind of like this, right?
Okay.
Quadratic function, so both sides will be up. And that is the end behavior. Have you learned end behavior of these functions?
We haven't learned these type of
Okay.
functions that go like.
Okay. Let's also find the y-intercept. From
Okay.
the equation, y-intercept is very clear. So what is the y-intercept?
The y-intercept is when all x's are 0.
Yeah, so x equals to 0 gives me y equals to what? So look into the standard equation, the last constant term. I think it was 2, right?
Yes. So it's 0. I'll just do it just for the sake of.
No, it is a constant term, yes.
So negative 1 times negative 2.
No, all those, okay. No, use your standard equation given in the question itself. Because here we have done approximation.
Oh, okay.
So your question gives you the constant at the end, right?
Oh, when f of x has to be less than 0.
No, in your question, the y value was x to the power of 4 minus x
plus
cubed.
2.
That last thing is constant too, right?
Oh, so would that be our value for our
Y-intercept.
Oh, because everything else would be multiplied by
0.
0, so that would give us. Okay, that makes sense.
Yeah, so that is your y-intercept. And now, since we know it, we'll just graph it, right? So
How do you graph this?
this is linear, kind of like this. That is how the graph is going to look. Polynomials are smooth curves.
Okay.
No corners, no cusp, all turnings, smooth curves, like we have shown. If you go from one x-intercept to the other, I mean, you have to return, correct? So we have turning points. Do you see these turning points?
Okay.
These turning points will give you maximum or minimum value. Here, turning point gives you minimum, and that is the maximum. Is that clear?
That's clear. So our y-intercept is our maximum value.
No. Between y-intercept and 1, somewhere in between, we have the maximum value.
So how would we, if we had to state it, how would we state the maximum?
Okay, one way, of course, when you graph it. Now, what we could do is we could check, we could make a table of values and check some values between at 0.5 and some values around 2, correct? Approximately in between these two values and estimate this value. Is that clear to you?
Okay.
In the equation given to us.
Okay, I understand. But usually they want us to ask us to state an exact. They'll just ask us to graph it and then just point the maximum.
Have you learned calculus?
No.
If you would have learned calculus, we would have found a derivative. And at turning point, derivative will be horizontal. So at this point, we have a horizontal tangent. You understand?
I don't know what a tangent is either.
That is correct. So therefore, we are not adopting those methods. We will adopt it next year.
Okay, yeah.
to find the
We
turning
have it
point.
because
And
one of the
at this moment,
questions,
yeah, at this
um,
moment, we are restricted to what you know, right?
yeah.
So we will just make a table of values and estimate using these points. Is that clear to you? You have
Okay.
an idea what this point could be. It is somewhere between -2 and minus zero point 0.4, correct?
Hmm.
Here we have a point which is between minus zero point 0.4 and 1, and then a point between 1 and 2.41.
Okay.
So approximate that, and then you can get the value of maximum and minimum values.
Okay. That makes
Right?
sense.
Okay,
Yeah.
great. So now you can go back to your question. We have answered most of it, and now we will relate it to your question. Is it okay?
Yes, that makes sense.
So, yeah, please. I'm stop sharing. You can share your screen now.
Sure. See, I figured out that some of the questions that I found on this online website,
Yeah.
they require some skills that I haven't learned yet.
So you can tell me which website from where you found. I can tell you. Okay, SL difficult hard. Yes. So when we talk about SL as an exam overall, they are
Yeah.
actually looking into your total curriculum, not just what you have learned so far.
See, I got it from this revision village and also this website right here. I don't know if you can see it at all.
Okay. You can send it to me later. Let's
Okay,
continue with our exercise.
sounds good. Let me go
So
back.
now it is absolutely clear that there are more skills which are required to solve this test paper, definitely.
Yes,
So
definitely.
with the restrictions where we are today, we have provided the best possible solution. Is that clear to you?
Absolutely clear.
Correct? Of course, I can solve the inequality also now. You know how to solve this inequality?
No.
I will solve it just now.
Okay,
So can you reduce the screen? We'll just solve the inequality right
sure.
now. We want the
It's
function to be negative. In fact, we solved it, but I'll show you here. So I'll make a graph here now. So you remember the graph? It was something like this. Correct?
yes. It was
You
up to here.
remember the points here?
Yes. It was 1 when x is 1, x is -2, x is 2.41, and x is -0.414.
What do you want? F of x less than 0 means negative.
So we ignore the positives and we just only look at this area over here.
You're right. So we have
Okay.
the solution right there, right?
Yeah.
So it is from -2 to
2
minus
to
zero point 0.4.
0.4.
Union, I'll write from 1 to 2.4. Is that clear to you?
We still include the 1 and 2.4?
No, they want less than, so will not include. So parenthesis, this kind of a bracket means not included. If I have to
Okay,
include, I will use a square bracket. You get the idea?
I understand. So for -2 and -0.4, we don't include these points
No,
either?
no,
Okay.
because we want
Oh!
less than 0, not equal to
Oh, I
0.
understand. So because the polynomial function is it's decreasing towards negative infinity, um, it has both of these points, all four of the points are in union, but they're not included. But the area that it covers is included?
Yes.
That makes sense.
So on a number line, if you were to show this solution on a number line, let me just show you here, right? So on a number line, you will say my solution is from -2 as a whole, right?
Yeah,
To -2 to minus 0.4 approximately, and from 1 to 2.4. Is that clear to you?
that's clear.
So that is the solution of inequality. We have already sketched the graph, and finding the other points is using calculus. So we are not using calculus. So
No,
next,
I haven't learned that.
yeah, next calculus. Is that okay?
Yes.
Not now. So we'll skip this.
Okay.
Clear. You can now ask me some other question. Is
Okay.
this clear to you? First thing.
This is
Absolutely clear.
absolutely clear.
We can
I
actually answer. We can actually answer the last part, the inverse function, right? Solve the equation f inverse of x equals to -1, right?
Yes,
We could do that.
we could.
How?
So we found the factored points from the remainder theorem that we did, but we'd have to use this first original. I don't correct me if I'm wrong, and we have to swap all these x points for y's, and then we'd have to do the remainder theorem again. But I don't know if that's the way to go.
So think like this. If on the inverse, the output is -1, that on the function, the input is -1, correct?
Okay.
So f of -1 is your answer, right?
Yes.
Just plug in
Oh,
-1, get the answer.
so you just substitute -1 on these points here and then solve here.
Correct. Because your output on the
Is
inverse is
-1.
-1, and we are saying it is a function.
And
When
the
we are
inverse
saying
is
it is a
just,
function, it will pass the horizontal line test, and there's
yes,
only a unique value. And before that, we're looking into A and B. So that
yes.
value between A and B, it will, make sense, the part C as a whole. You get the idea.
Yeah, so whenever even if this wasn't a polynomial function, let's say they ask f of -1x is like -1, and this is like x squared plus 3x plus 4, for
Yeah,
example,
just plug it in,
you
get
just
your
plug
answer.
in the -1 because the inverse is basically where all outputs become inputs and all inputs become outputs. It's just the
Yes.
swapping.
So
Okay,
even if you don't know how to figure out what is the inverse function, but you know the answer, you get the idea.
just put it in.
Just put it in.
That's so easy. Wait, I would have gone and done the whole thing. We're swapping x and y. That's so like simple.
Yeah.
Okay, I'm gonna go to the next
Sure.
question.
Sure. Sure.
Um, sorry.
No problems. Yeah.
Yes, okay, it was this one. I don't know
Okay.
if this is
Read
too
the
long
question.
for
Read the
today.
question.
Okay, let me just get my paper. So
I'm
let
liking your selection of questions. They're very beautiful. Excellent questions.
Thank you. I picked the hardest ones so
Good
that
job.
we
I
can
like this.
figure.
Hard things is good. Some
Let
exercise.
f of x equal 2x squared minus 8x plus 6 for x is an element of the reals. Write down the value of where f is 0. So
F of
your
0 is 8, 6, right? Y-intercept, first one.
oh yes, because well it's the constant, so
Hmm.
that makes sense. So that's 0. Solve the equation where f of x equals 0.
Correct. So so you could easily solve this. First you factor 2, right? So first you factor 2, you get x squared minus 4x, and then
Plus
you have plus
3.
3, correct?
Yes.
And 3 is like 3 times 1, both negative. So 2 times x minus 3 times x minus 1. Do you see that?
Yes.
So we have a solution x equals to 3 and x equals to 1. Is that clear to you?
Yes, that is clear.
Good. Next.
Okay, yeah, so I have done this question because these answers are very familiar. So I think the
Okay.
issue came down from this E part.
I get you. We'll go through it and then
Well,
come to
let's
you.
go through it though, because I
Yeah,
just now I'm finding like little tricks where like you told me, oh, the constant, if you're putting the 0 in,
yeah.
I wouldn't think that at first. I'd go through the whole step just to find the 6. But if it's like x and you're just putting a value of 0 in, then obviously the
Yes.
constant would be your answer.
Perfect. Yeah, read this. The function
Okay.
f can be written in this form, vertex form, right?
Yes.
Find the
So
value ahk.
so the first thing we'd have to do is we'd have to turn this into we have to complete the square is what I do.
Okay.
Just to find like the vertex and then solve for a
Correct.
because we do have like points.
Correct. Correct.
So what I do is 2x squared minus 8x plus 6. And so I'd factor out the 2 from the first two values. So it'd be 2x squared minus 4x plus 6 outside the bracket.
Correct.
And then 2x squared, and then you have to do b over 2 squared. So that would be minus 4 squared, which is minus 2 squared, and that's 4. So it's x squared minus 4x plus 4 minus 4 outside the bracket plus 6. And then 2 is x minus 2 squared minus 8 plus 6. And so then this is 2x minus 2 squared minus 2. So that's
Perfect.
in vertex form.
Perfect. So you have all the points here. You know what the value of a is,
Yes.
And you know everything now, right? So you know a is equal to 2 for you, and then what, h is equals to 2 for you, and k is equals to minus 2 for you. Is it okay?
Yes.
Good.
The
So you have your
axis
work.
symmetry, we do minus b over 2a, right?
Correct.
So axis of symmetry is minus b over 2a.
Which
So
you know
the
from vertex from directly x equals to 2, right?
oh yeah,
Yeah. So once you have the vertex form, read from there, right?
yes,
Correct. So coordinate of the vertex, you know now.
yes. So the coordinates of the vertex is 2 minus 2. And so now we want to find the axis of symmetry. So what I'd do is I wouldn't look at the vertex form. I'd actually look at the function in standard form because that gives you your a squared bx plus c. But I don't know if there's like another way to do it.
Vertex form. Just check the vertex form. X equals to 2 is your answer for axis of symmetry, correct?
Oh, is that because if you were to take the argument out and make it equal to 0, then x would equal to 2, which is
Yeah.
the same thing as your axis of symmetry?
Yes.
Okay. I think that's what we did with our the logarithms last time, where we had to find the argument and we wanted to find the domain, I believe. So we made the argument greater than 0 and then went
Correct.
from there.
Correct. Now the
Um,
graph of the function g is obtained from the graph of f by reflection in the x-axis, followed by a translation by a vector 1, 3. So, okay, so can you do this? Reflection on the x-axis. So find the value of g of x.
so f of x equals, we're going to use the vector, sorry, not vector form, the vertex form, 2x minus 2 squared minus 2. And there's a reflection on the x-axis, meaning that we would put it in front of the vertical stretch because that means that it's to the y value.
Correct.
So it'd be minus 2x minus 2 squared minus 2. And now with vector notation, the 1 on the top means that it is a horizontal translation, 1 towards the left because it's written, no, sorry, 1 to the right.
Right.
That means we write it as minus 1. So it would be minus 2x minus 2 minus 1. I believe squared minus 2, which is minus 2x minus 3 squared. Is it not minus 3?
No, because you're moving 1 unit to the right. So when you move 1 unit to the right, so it is minus 1. Yeah, minus 3. Correct. Correct.
No, because we go minus 2 minus 1, right?
Yeah. Minus
Okay.
1 unit to the right. You move
And
further.
and then the y value right here is 3, meaning we're going 3 units upwards. So then to the minus 2, we'd be adding 3. So we go minus 2 plus 3, which is 1. So then our function of g of x is minus 2 x minus 3 squared plus 1.
Correct. Now you can expand it, right?
Okay. Oh, so they're just asking for standard form over
Yeah,
here.
yeah.
Okay. So I'd go minus 2x squared minus 6x plus 9 plus 1, which is minus 2x squared plus 12x minus 18 plus 1, which is minus 2x squared plus 12x minus 17, I believe.
Yes, you're right.
Okay,
And you can now know PQ and all. Perfect. Easy.
perfect.
Good job. So I think we can conclude now at this stage. We can continue from here in the next class. Is it okay?
Okay. Yes, that sounds good.
Great. So I'd like you to summarize today's learnings. So you can stop sharing the video and you can summarize what have we learned today. Yes.
So what I believe we've learned today is how to use the remainder theorem. So when you have to do higher order polynomial equations, that's how you basically factorize them. And when you want to factorize them, you want to look at your constant value and the numbers that are given as primary factors.
Factors of that.
And
Perfect. Good job.
from from there, basically that's how you'll find what equals to 0 when you plug it in. And then you keep, I guess, doing the division until you get an equation that's not factorable. And then you use the quadratic formula to factor that, and then you'd go from there. And then we learned how to do transformation, so plugging in transformations through like vector notation and also graphing in general. And today I learned that you don't have to always plug in the 0 when you want to find what the y value is, because it's pretty self-explanatory. You look at the constant, and in a composite function, if they give you the output value, so like f of x equals -1, and they want you to find like the answer of f of x, you just plug in, you do the inverse, and you just plug in the -1, for example, into the actual original equation, and that'll give you the answer, because it's just the output turns into the input and the input turns into the output. So it's just like that. So I think it goes the same with like domain and range as well, where the domain of the composite function original is actually the range of the new function, and the range of the new function is actually the domain. Just domain, it's like the same thing, swapping.
Correct. Great. So
we learned
that
a
was
lot.
nice. And I really appreciate the selection of your questions. We went through variety of questions today, including exponential, logarithmic, quadratic, and polynomials of degree 4 for grade 11 student. That was great job. Great. Thank you. All the best.
Thank you.
Thank you.
Have a good day.
You too.